Okay, we are reviewing for the test, and the test is not Monday, it's tomorrow. Surprise! I'm not kidding. Yes, it's really tomorrow. And by the end of the hour, you're going to go, oh my gosh, this is actually really easy. Because we're done. I've already taught you everything you need to know. It's not going to be that bad. Really isn't. All right. I know you had it Monday in your head, but that's based on faulty information, which was that I had more new stuff today. Today was supposed to be new stuff, and then tomorrow's review. There's no more new stuff. So it's just a review day today, and then the test is tomorrow. It's okay. I think you'll see. It's really not that bad. And I even decided, because I had told you that the test I thought was going to be Monday based on thinking I had another new lesson today, I told you guys it was going to be Monday, so I'm even going to provide an extra morning help. Normally I don't meet them on Fridays for morning help, but I'm providing an extra session tomorrow in the morning, 7:05. If you look on the board there, it doesn't say Friday, does it? But I'm doing Friday, 7:05. So if you really want some extra help, you can get it. Okay? And you also could stay after school, but not today, because again, I'm gone. So that's another reason why I feel like I should provide an extra morning help if you want it. But I bet you're going to walk out of here today and saying, this isn't that hard, because it's another pretty easy test. All right? But by the way, that also means if you have trouble on it, these two tests have been pretty easy. The average score has been like an A-, and you're getting C's every time. That's a sign that something's wrong here. Maybe you're in a class that's a little too difficult for you. If you're having these easy tests and they're hard for you, wait till we get to the hard tests. You know what I'm talking about? All right. So here we go. There's 3 questions, A, B, and C, that are about these functions. Just ignore the little red dot there. 2x squared plus x over x. And it doesn't say what the domain is, but it's implied, as in you can figure out what x has to be. Remember, a domain is not, here's things that it can't be. A domain is, here's a list of everything that works. So the way I like to usually start this is that pretty much everything works in functions. So you say from negative infinity up until something that doesn't work. All right, so f of 3, just stick a 3 in the function, put it in the right one, no big deal. I did put a g of x function up there because I wanted to do maybe a composition of functions, but I decided that isn't important yet. In our next chapter, we're going to do composition of functions. So don't worry about putting a function inside a function yet. We'll be doing a lot more of that next chapter. Okay? All right, try to answer A, B, and C. I hope these are pretty easy ones. On C, hint, you need to multiply it all the way out and simplify it as much as you can. Okay? So I know once you stick in x plus 2, this part's going to be a little icky. Well, yeah, that's part of the difficulty in pre-calc is the algebra. All right? So try to answer those 3, and I'll come back from a pause in a minute once you've had a chance. Okay, let's see. When you stuck in a 3, you should have had 9 times 2 is 18, 19, 20, 21 over 3. Did you get 7? Raise your hand if you had 7. Okay, awesome. Now that's the easy level. Then domain, again, this is a pretty easy one, you have to admit, because it doesn't even have a square root in this one. So its domain is pretty simple. The only thing that can crash it is if the bottom becomes 0. A lot of kids get confused and they try to figure out what makes the top 0. That doesn't crash it. If the top is 0, the answer is just 0. If the bottom is 0, it crashes. So it's from negative infinity until, that's a great way to start because it reminds you a lot of things work in these functions. It works until you hit what? 0. And then it starts working again after 0. Raise your hand if you had that one right. Okay, awesome. And then f of x plus 2. You put in the x plus 2 wherever there was an x. I like to have this little empty, I like to call it the skeleton form of the equation. Looks like little rib cages. And then you drop in whatever they tell you to right here, which is x plus 2 in this case. Final answer. Please don't be one of these people that thinks that you can cancel that and that. Do you get, some people might think that. You can't. Why can't you? Yes? All right. And another way to say it is you can't cancel when it's part of an add problem like that. Again, 1 plus 4 over 5. that we know that that should come out to 5 over 5. And if I cancel it like, I'm sorry, 1 plus 4. If I cancel like this, oh man, that actually, that's a terrible example. I'm sorry, here's what I meant to do. 2 plus 3 over, let's say 3, okay? And if I cancel these like this, it doesn't work because it would be technically replacing with 1s. The answer should be 2. But we know that 3 plus 2 over 3 is 1.5 over 3, which is not 2. Okay. Or 4, sorry, I was thinking 4 over 3, which is 1 and 4 over 3 is 1 1/3, and it's certainly not 2. All right. I know I'm spending a lot of time telling you not to cancel that, but I'm telling you, there's so many kids that still think you can cancel that. I'm getting the tests, and I'm looking through the tests, and they're like, cancel, cancel. You can't do that. Okay. So, okay, that's a good question. So, if we get this factored, and there's an x plus 2 in both of them, then we might be able to cancel it. All right, so one thing at a time. I'm going to now multiply this puppy out. 2 and then x plus 2 and then x plus 2. Do you get what just happened there? I broke up the squared. Plus x plus 2 all over x plus 2. Now, FK, I think you have a good idea. What are you telling me I should do? Don't use the word get rid of. What's my favorite thing? What's my favorite thing? Not canceling. So if you can factor it, you should. Think about what you just are saying in terms of the word factor. There you go. Factoring out the x plus 2 from the top. I know a lot of people didn't even see this. That and that, there's an x plus 2 in both of them. So that can come out. And then what's left over when you factor out the x plus 2? You would have a 2x plus 2 plus 1 over the bottom, which is x plus 2. And so you are totally right, FK, which I'm just saying because this is a video. That can cancel that. You are right. And this is what's left behind. Now, I know a lot of people would have never caught that in 100 years, but do you get how the top had an x plus 2 in 2 parts? That's why it could be factored out. Once it gets factored out, then it can get canceled. All right, so final answer is, now you could have gotten to this a different way, as long as you ended up having 2x plus 4 and then plus 1, which is 2x plus 5 is the final simplified answer. That had a wicked little twist, and I'm going to show you one more time. Do you get there was an x plus 2 here and an x plus 2 there, and they could get factored out to the front and put out here in front, where it then can be canceled because it's a factor, it's a multiply. All right, that was icky, I know. A lot of you at least knew how to put this in, and I'm sure some of you just multiplied this all the way out and thought, okay, I'm stuck, there's nothing else I can do. But you could have factored out an x plus 2 and canceled it. All right, so let's talk about one that's got a square root in it. There was one on the other screen, but it was getting too messy. That. What's the domain of that? Can anything just work in that? No. But you would say all real numbers except it has to be from here to here. Okay, so does it work from negative infinity to... No, it doesn't. Because negative numbers like negative infinity is certainly not going to work in here. So my best advice on this kind is set this. Who remembers the little equation? You're supposed to set that greater than or equal to 0. Awesome. So finish the deal. Now, if you wanted to say this in an interval, it doesn't go from negative infinity. It only starts working at negative 5 until it stops working, well, pretty much never. It keeps working the whole way. All right, so there's your interval notation way to write it. But didn't you say, Mr. Server, to use a number line? I said to use a number line when they've got complicated, when they got like a bunch of things like this. 2x minus 7 over x squared minus 1. That has all kinds of domain issues. There's things that would crash your square root. That's one equation, hint. Then there's things that would crash the denominator. It's another equation you can write. And then you should put it all together on one number line. This one's difficulty level R3. Not impossible by any means, but check with the kid next to you once you're done with this thing. What I would do is have a number line. Show them your number line. Number line is an appropriate form of an answer. It's not like you always have to change that to set builder, or you always have to change it to interval notation. Number lines are okay. Sometimes we require set notation or set builder or interval, but we'll tell you when that's the case. All right, I'm going to pause. We give this one a try. Okay, so this, you should have said 2x minus 7 greater or equal to 0. So add 7. 2x greater than or equal to 7. So x greater than or equal to 7 halves. A little bit of a pain, but you got to get used to those mixed numbers. That's the same as 3.5. Okay. Then down here, if you can factor it, you should. And if you haven't figured this out yet, 1 is 1 times 1. So therefore, it factors like that. And then I make a big old number line and say, okay, -1 doesn't work. I'm going to call it u. Does anybody know what u stands for? Undefined. It makes this function undefined. Okay. Then, here's where 3.5 is, also known as 7 halves. And it works there, and it keeps going forever this way. So all of this didn't even really matter, did it? Because the domain's going to be 3.5 and bigger. Raise your hand if you had that one right. Okay, good. I would make your, if you catch that, if you notice that, you could have just said 3.5 to infinity. Now, yes, 7 halves is the same as 3.5. That'd be fine. That's not the bell, of course. All right. So if this 3.5 had been negative 3.5, like way over here, do you get that would have made it much more complicated? Because then it would have been up to here, and then it stops working again, and then it starts again, and then it stops working again, and then it keeps going like this. That's if it had come out to negative 3.5. Then you would have had 3 little blocks that work. It worked in here, it works in here, and it works in there. Sometimes we do that too. Okay. So here's one more type of question that we've been working on. Domain and range from a picture. We've done this one before enough times where you're like, okay, everything works except 1. I think you're good enough at that. What if I make you a strange little drawing where this works, but that doesn't? And I'll tell you that this is this at 12, 1. That's this point right here is 12, 1. And this spot right here, I was a little sloppy with this. I should make sure it's clear. This is this, and I'll make a dot there. What's the domain and range if that point is 1, 10? What's the domain and range of that function? You know it's a function because it's past the what? The vertical line test. The reason you have to say vertical line is because actually this year you're going to learn the horizontal line test. It does something different. The vertical line test tells you one thing. The horizontal line test tells you something else. Yes, sir. It's a good question. You don't have to write the function here. If you were trying to write the function, then you'd need to know exactly how far to been shifted and everything. All I'm asking, domain, range. All right, I'm going to pause for a second, see if we can do it. All right, domain's all about the x's, right? So from 1 to 12, if you were going to go really fast, you go like this. Range is from 10 to 1. Oh my gosh, I just made so many mistakes in there, it's ridiculous. So tell me, what did I do wrong? It's kind of got some right things, but if you're like, what? That's what I said the answer was. Yes? Yes, The range has to have the smallest number first, or I have to mark it wrong. Okay, so range goes from 1 to 10. There are still mistakes. Explain. Sir. Brackets on what? Domain 1, because that 1 actually works, right? Okay, and then what else on the range? All right, the 10 on the range, because again, at this spot for the y, it works there, so bracket there. If you were missing those, I'd have to mark it wrong. Marzano is pretty brutal on that. Remember, you can get 3/4 of them right and still get an A with Marzano, but every extra problem you get wrong after that takes you down a whole grade, so you can't afford to make mistakes. I double check my parentheses and brackets. I have to mark that wrong all the time for kids. Any questions about that one? Okay, then we should move on, as the cow said. Would you please tell me what's the domain of that? This one messes with people's heads. Somebody's gremlin just came out of their head. All right. That was a strange little laugh. So, did you figure out that the top factors? The thing I'm scared about is what you're going to do at the bottom. We can only factor that using imaginary numbers. That can't be factored. What does that tell you? Well, here's another way to say it. What's in the bottom here has to not equal 0, right? Because if it equals 0, we'd have a problem, right? But how are you ever going to make that equal 0? X squared plus 16 has to equal 0. Then x squared would have to equal negative 16. How are you ever going to get something squared to equal a negative? Only with imaginary numbers, and therefore you can't do it, and therefore you can't crash it. And therefore, what's the domain? All real numbers. So don't just sit there and be like, well, I can't do this one. Well, you can't factor it, and you can't make it equal 0. That doesn't mean you can't do it. That means nothing will crash it. Now, other people are like, but you can put in 10. Yeah, you can put in 10, and that does something, but it doesn't crash it. What does putting in 10 do? Put in a 10 here, and a 10 here. That's going to be 20 times 0. It makes the top 0, which makes the whole thing 0. Yes. So moral of the story, don't worry about what makes the top 0 unless we've asked you for what makes the whole function 0. Why would we ever do that? Watch. The function is equal to this, right? F of 0 would be easy. If I say f of 0, what are you going to do? You're going to stick 0 into the x, and you're going to get, just do it in your head quick. No, it's not 0 on the top. There is a 0 involved, but what would the top be if I stuck in a 0 for the x? Top would be negative 100 over bottom is, so it's just it's a number. It's kind of an icky number, but it's a number. What is that? Think. What is that? We just set x equal to 0, so you were finding the y-intercept. So if we asked you for the y-intercept, you'd set x equal to 0. What if we asked you for the x-intercept? Set y equal to 0. Where is y? So that would have to equal 0. How could that equal 0? How could you make the whole function equal 0? Said it 2 seconds ago. You make the top 0, which some other person said would be what? What would make the top 0? 10 and negative 10. So do you sometimes care about the top? Yes, but only if you want to find where y is 0, which tells you the what? The x-intercept. Okay, so here's my question. Another one like this. Find the x-intercept, find the y-intercept. for this. Find the x and the y intercepts for this function. I'll pause for a second while I give that a try. All right, do you remember the old statement, if you can factor it, you should? Let's factor that top puppy. X squared comes out, what do you got left? X squared minus 1. Now, some people need to process that for a minute. Do you see what just happened on the top there? There was an x squared in this one, and there was an x squared in this one. I was able to rewrite it like this, factoring out the x squared. And it's sad, but true, that a lot of people can't do that. Well, if I multiply this back out again, I might show you where it came from. X squared times x squared would make my x to the fourth, and x squared times the negative 1 would make my negative x squared. See? Now do you get that the top's been factored? All right. Then I'm going to factor it again. Because if I can factor it, I should. Now, why was that so important? Because we were trying to find the x and the y intercepts. The x-intercept is where, finish that sentence, y equals 0. This is where y is, so you'd set that equal to 0. Did you get 3 answers for that? I know you know this one. I know you know this one. But did you notice that that also, x equals 0, will make the top equal 0? And some people mistakenly include negative 7 in the list of things that make it equal 0. Do you get why they might do that? Because it makes the bottom 0, but it doesn't make the function 0. So don't include negative 7 in your list. All right, negative 7 would be a good thing if you were asked what crashes the function. I did not ask that. I asked for the x-intercept and the y-intercept. Okay. So what were these again? Well, y was 0. So if I was going to make a little list of points, their y is all 0. And the x's were 0, negative 1, and 1. Okay. So those were the, I can tell, x-intercepts because their y is 0. How about the y-intercept? That's where x equals 0. So you just have to stick in a 0 here, and here, and here, and pretty quickly, I hope, you'll realize that, what do you get? 0. Is that an okay thing? Yeah. What do you think that means? It's 0, 0. Think about it. It's the x-intercept and it's the y-intercept at the same time, isn't it? Ah, mind's blown. Have to get some paper towels. All right. So let's talk about something else. Do you remember the Franken functions? They were part this and part that and part the other thing all sewn together. All right. So I'm going to give you a Franken function, and I want you to write this thing. I'm not going to say the answers, like this isn't the right answer for the one I'm going to do, but it looks like this. That kind of thing. Do you know what I'm talking about? 0 to 2, and then 2 to infinity, that kind of thing. Okay? You know what? I'm too lazy to go do it the other way. I'm just going to have you take that one and graph it. Because it'd take a lot of hard work. And frankly, I tried to do it that way last hour, where I drew the picture, and then I had done one part of it wrong, and that screwed everybody up. So how about we not do that? I'll make it more clear where the brackets are and stuff. Bracket on the 0, parenthesis on the 2. Bracket on the 2, parenthesis on the infinity. All right, so you need to graph this one. Do you remember me saying the trouble on these is always at the border? So in other words, don't by accident make this thing fail the vertical line test, for example. And also, another thing that comes into play, oftentimes kids have a hard time because they don't make a what? XY chart. Correct. I strongly recommend the XY chart. Because trying to picture exactly where this function is, but only in this zone, is very difficult. But just making an XY chart and finding some points, pretty easy. All right. Pause, give you a little time to chew on that one. Okay. I want to point out that somebody has noticed that this function isn't going to start working until you hit 4. That's okay. It's okay to have a gap in the function. But I get that it's also kind of misleading because it indicates that it can be 2. So I would just have graphed this and had a gap in the function. There's the 12-minute warning. So that means we're getting close to the end here. All right, so let's finish this up. Would you agree that this is a parabola up until it hits 0? So basically, kind of like that. Raise your hand if you had something kind of like that. Awesome. Then, does it own 0? No, so I'm going to put an empty spot there, and then let the next function take over. The next function is the absolute value function, which kind of goes like this. How long does it keep going? Until x is equal to 2. So let's say that I make that a little less, make it like to there, is where 2 is. And then, does it own 2? No, empty spot. And then another function takes over. And a good point was made that when you put in 2, it can't exist. So there's a gap, and when you put in 3, it still doesn't exist. When you put in 4, it finally exists. And when you put in 4, what is the square root of 4 minus 4? 0. So it's down here when it picks up and starts working again. How do I know that? Well, I can make a little XY chart for this. And I can put in 4, and I get square root of 0, which is 0. And I could put in 5, and I'd get the square root of 1, which is 1. So over 5 and up 1 is a spot. And basically, it takes off from there and keeps going forever. There's my Franken function. Has a weird little gap like this. We don't normally do that, but it's not illegal. You know what I mean? This still passes the vertical line test, doesn't it? Okay. How many think you can handle that? All right. And if that is like, oh, no, I am not getting that at all, sign yourself up for, you don't have to do anything. Just show up tomorrow morning. I'll be here in this room from 14:30. You can get some more help. All right. Next topic. We've done almost everything I can think of that you could possibly need to know. There's always, room for being stretched a little bit. How about if I turn it over to you? Is there any topic over the last few days that has really bothered you? I can't talk about the R4. It's like the first rule of Fight Club. Can't talk about Fight Club. Yes? Okay. I don't think that that's going to be super easy for everyone. But let's talk about this one for a minute. When it was just y equals x squared, would you kind of know what that was? Okay, that's a parabola, right? So then the question becomes, if I say minus a, what does it do to my parabola? Here's my parabola. Does it give me a family of parabolas that are like getting stretched like this? Or narrower? Is that what happens with the a change? No. So you're trying to draw something like this to help yourself figure out what's going on. That would not have been the right thing. What does happen to this family of parabolas as a changes? Yes, it goes up and down. So the whole parabola could be moved up, moved up, moved up, moved up, or it could be moved down, moved down, moved down, moved down. What if I told you that a had to be positive? Like a has to be greater than 0. Then does that narrow it down a little bit? And it's a little counterintuitive because you might think, oh, a is positive, so this thing must be moving up. That's why it's smart to actually try a number. So what is a nice number that's a little bigger than 0? I like it. 1 has weird properties, so let's use 2. Okay? So if, oh, sorry, I put the 2 in the wrong spot there. We're going to let a be 2. Now, you see where it went? It went down, didn't it? You might have thought, oh, a is positive, so it's going to move up. No, there's a minus in your equation. So when you actually put in a number like 2, that means the whole thing just went down 2. Do you get if I make it 3, it's going to go down further and down further? And so I can tell this family of functions just goes down that way. That's the main thing I want you to know about that kind of problem, is that you can make a family of related functions. So let's say I had one where the n in front of the x squared. Again, it really bothers people to like mess up. You would know what it is if it was just x squared. The n, I don't know what to do. Well, just think about it. If you put in some numbers, what could that do to your parabola? Stretch it. So if your parabola normally looks like this, do you get stretching it can also mean shrinking it if you use a fraction? Okay, so your parabola could get narrower, 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 or wider, wider, wider. Somebody smart tell me what else it could do. Yes? It could be negative, and therefore what? It could cause the parabola to flip over and be like this. So all of a sudden my family of parabolas that are related here looks like a giant scary spider with like 14 legs. So what would that tell you about the domain and range of this thing? It'll be all reals because it could go in every direction then. All right. This is a good topic because this is something that really confuses people on the ACT too. They throw in an extra letter. And the biggest tip I can give you is put in a number for it and see what happens. Like put in 1 and see, oh, it's just a regular parabola. Put in 2. Oh, I guess it's stretched. Put in -2. Oh, it's stretched and it flipped. So those are all the things that could happen to my parabola. All right. This test is not that hard, but I would study. How would I study? If I were you, I would go back and do all the problems that I in the past have told you could skip because they were like extra ones. Well, that'd be the perfect worksheet. I can't make you do that, but if your life depended on getting an A tomorrow, you probably would take a lot of time to practice, and that's how you could practice if you wanted to. If you're feeling totally solid, go ahead. You can take the test. The worst case scenario, you can just have a retake on it. It's a little bit of a pain for both of us, though, if you bomb that test, because then you got to come in and do corrections. Then I got to check and make sure your homework's done. Then I got to make sure that I put a test in the testing room, and then I got to grade the test in the testing room. So please, just study in the first place. All right, that's all I got for you for today.